Hello everyone, welcome to the channel. In this video I'm going to show you the global LULC change analysis from 2000 to 2024 using MODIS MCD12Q1 dataset in Google Earth Engine. Now let's get started. The land use land cover change analysis is a critical component of global environmental monitoring as it provides valuable insights into the dynamics of the terrestrial ecosystem, human activities, and climate interactions. Over the past few decades, a rapid urbanization, agricultural expansion, deforestation, and land degradation have led to a significant alteration in the Earth's surface characteristics, causing various impacts. Continuous monitoring of these changes helps the policymakers, scientists, and environmental planners to understand the land transformation pattern and the ecological and socio-economic implications. In this study, a multi-temporal global LULC analysis was conducted using a MODIS MCD12Q1 land cover type dataset with an Earth Engine platform. The MODIS product produced annually at 500 meter spatial resolution provides a consistent global land cover classification from 2000 to present. The dataset utilizes the International Biosphere Program classification scheme, which categorizes the Earth's surface into 17 major land cover types, including the forest urban classes, the forest subclasses, shrublands, savannas, croplands, wetlands, and urban areas, and barren land and water bodies. The workflow implemented in Earth Engine, it automates the extraction and computation and visualization of land cover data across multiple years. The analysis begins with defining the study region and loading our annual MODIS land cover type images from the period 2000 to 2024. Each image is clipped to a study boundary to ensure the spatial relevance. The code then calculates the total land cover area in square kilometers for each class and year by multiplying the pixel counts within pixel area using Earth Engine built-in spatial reduction functions. The result is a comprehensive year-wise feature collection summarizing the areal extent of each LULC category across a 24 years period. And the visualization parameters are clipped to display a spatial distribution of MODIS IGBP land cover classes using distinct color palettes. This system allows the user to select and visualize any specific year between 2000 to 2024. And additionally, further spatial and temporal analysis. Last, we're going to export this image in the GeoTIFF file format for any selected year of your choice, and a CSV summary table containing the yearly class-wise area statistics to our Google Drive. And this export functionality ensures the compatibility with external GIS and statistical tools for extended geospatial analysis and reporting. Further to facilitate the interpretation of the long-term changes, the code also generates a time series chart. It shows the temporal trends in land cover areas for all IGBP classes from 2000 to 2024. This visualization provides a clear understanding of the magnitude and the direction of the land cover transition, such as an expansion of urban cropland areas, the reduction in forest area, forest cover, or the variation in the wetlands and water bodies. Helping to identify the dominant land transformation patterns and anthropogenic pressures. Overall, this automated MODIS-based workflow demonstrates the potential of Earth Engine for large-scale LULC monitoring. Now let me get back to Earth Engine here. In our first step, we're going to define our region of interest. For example, in my previous analysis, I've defined Tamil Nadu as one of my region of interest here. This is the coordinates I've created earlier. In case if you want to use a different study region of your choice here, for example, you can select this particular tool called Draw a Rectangle, and you can navigate to any study area of your choice here. For example, I'm going to select all this area as my study region, and once you did that, in the top section we have a new variable has appeared, which is called as a variable geometry. In that, I'm going to navigate to the option. I'm going to click this option here, and from here we have this newly created geometry. This is the latitude and longitude of our newly studied region here. You can copy this using Ctrl+C from your keyboard, and once you copied it, you can paste inside this variable here. So you can paste using control V. So to paste those coordinates, we're going to mention this control V here. So let me show you that. So we're going to remove this. So we're going to paste the coordinates inside this variable. So now here you can able to see I've pasted my latitude and longitude of my newly created study region. So you can run this code, and you can just download the land use land cover of this study region and also the time series. So in case if you want to use the shapefile here, for example, so let me so in case if you want to add a shapefile into this analysis, so for that we're going to navigate to this option called asset section here. So in the asset section, you can able to see here, for example, we have different study region of a choice here. For example, I'm going to import this particular one called this particular the shapefile called Kerala here. So to import this, I'm going to click this option called import into the script. So once you did that, we're going to visualize this particular variable. So in the top section, we have the table, project, Earth Engine, Terra, Spatial, Asset, Kerala. So you can able to see that we have added our Kerala shapefile here. So you can select enter the suitable variable name of your choice. For example, the default is going to mention as study area. So this is my default study area. So you can use this name here. And in this way, you can use both of you can define your study area using this tool called draw a rectangle tool here. So you can use either use this particular option, or you can use your shapefile to proceed our analysis. So in my case, I'm going to use my shapefile here. So we're going to delete my geometry variable here. So in our first step, so we have to created our region of interest, that is our study area. So in the next step, I'm going to center this particular layer using map.center object study area with the suitable zoom level of your choice. And in the next step, I'm going to add this layer using map.addLayer study area with the default visualization parameter, and we're going to output the layer name as study area. So in the next step, we're going to load our MODIS land cover type dataset here. So to do that, we're going to mention variable MODIS LC equals to Earth Engine.image collection MODIS 061 more MCD12Q1. So in this way, you can add your MODIS dataset into Earth Engine. So before proceeding further, let me explain about this dataset here. So this is MODIS MCD12Q1 061 MODIS land cover type early global 500 meter resolution, and the dataset availability is from 2001 to 2024, and the dataset provider is NASA LP at USGS. And using this particular code, you can access this particular dataset here. And these are the following tags, and the description about this data is Terra and Aqua combined moderate resolution imaging radio spectroradiometer land cover type version 6.1 data provides the global land cover types at yearly interval. So the MCD12Q1 version 6.1 data product is derived using the supervised classification of MODIS Terra and Aqua reflectance data. And these land cover types were derived from the International Biosphere Program, the University of Maryland, the Leaf Area Index, and Biogeochemical Cycle and Plant Functional Types Classification Scheme. So the supervised classification then underwent an additional post-processing that incorporates the prior knowledge and the ancillary information to further refine the specific classes. So additional land cover property assessment layers are provided by the Food and Agriculture Organization, the land cover classification system for the land cover, land use and surface hydrology. So you can go through this documentation using the following set of link here. So the user guide, algorithm, theoretical basis document, and general document. So in the bands, these are the following set of bands that is available. So the resolution of this particular data is 500 meters of resolution, and these are the following set of bands that is available inside this dataset. So we're going to specifically use this particular band called the LC type 1 class table. So it has around 17 classes, starting with evergreen and deciduous, mixed forest, and open shrublands, woody savannas, and permanent wetlands, urban and build-up lands, croplands, and permanent snow, and last we have our water bodies. So these are the following set of classes that is available in this data, around 17 classes. So let me get back to Earth Engine. So to fix our time period of our analysis, so the dataset availability is from 2001 to 2024. So first we're going to define the year available. So starting using the variable called years equals to Earth Engine dot list dot sequence, starting with the start year is 2001 and the end year is 2024. So in the next step, we're going to set the visualization parameter for this particular dataset. So to do that, I'm going to mention another variable called IGBP_vis, that is visualization, and we're going to set the minimum of 1 and to a maximum of 17, which represents the 17 different classes inside this dataset. And color palettes, we are fixing each class as an individual set of colors here, starting with 05450A up to 1C0 DFF. So this color codes can be easily can seen from this this data here. So the first color which represented for the evergreen, and the last color which is going to be represented for the water bodies, so which represents the 17 classes here. So once you mention the visualization parameter, so the next step we're going to define the MODIS class names here. So to define the class names, so we're going to export this particular dataset as a CSV for the year from 2001 to 2024, containing the area of each of this land use classes in square kilometers. So first we're going to define the MODIS class name, starting with the variable class name is equals to Earth Engine dot list. Starting the first class is the evergreen, and followed by another evergreen, and next is a deciduous, and up to water bodies. So once you define your class name list here, so in the next we're going to define a function to calculate the land cover area per class per year. So to do that, first we're going to define a function called get LULC year, and inside this loop we're going to mention the year is equals to Earth Engine dot number year. And this particular year, you can able to see we have defined this particular variable earlier. So this variable which shows us the year, the unit of our study, the unit in year that is represented as year. And the next is we're gonna mention a variable called img is equals to MODIS LC, referring to our MODIS imagery. And in that we're gonna apply a set of filter functions here using dot filter, Earth Engine dot filter dot calendar range, and the start year and the end year, and the unit is in the year. So the start year is 2001 and the end year is 2024, as we mentioned earlier in our code here. So you can able to see this. Similarly, in that we're going to select the first image out of it. So to do that, we're going to mention another function called dot first function. So select the first image out of the collection. We're going to mention dot select we're going to mention dot first function, and the next we're going to select dot select. We're going to select this particular band called LC type 1. So in the MODIS image we have different bands here. For example, this particular band is LC type 1. This is our interested band. So it contains following 17 classes, and it also has another bands here, for example LC type 2. So it contains a different set of classes. So it has around 16 different classes here. So you can able to see the different LC type classes here, LC type bands here. So you can able to see. So out of this we're going to select this particular band called the LC type 1. So to select that, we're going to mention dot select LC type 1. And the next step, to filter based on our region of interest, I'm going to mention dot clip study area. So in the next step, we're going to define another variable called pixel area. So to calculate the area of this land use classes in square kilometers. So to do that, we're going to define another variable called pixel area is equals to Earth Engine dot image dot pixel area function dot divide 1:10 power 6. So now it's going to convert from meter square to kilometer square. And the next we're going to define another variable called area image is equals to the pixel area. So representing this particular variable containing each of the LULC classes in square kilometers. And we're gonna add this particular image. There is our MODIS using dot add bands img. And the next step, we're gonna compute the area per LULC classes. So for that, we're going to mention another variable called stat is equals to area image dot the reduced region. So inside we're going to mention the reducer is earth engine dot reducer dot sum, and dot group, we're going to mention the group field as 1 and the group name as a class value. And the geometry we're going to mention as a study area, and the spatial resolution of this MODIS image is around 500 meters. And the max pixel value is 1:10 power 13. And the next step, next step, we're going to create a dictionary with key groups, and each item in the list contains a class value which has a numeric class code and sum of total area for each of the classes. So to do that, we're going to mention another variable called groups is equals to earthengine.list stat.getGroup. So the stat which represents this particular variable here, so you can able to see that. And so basically what it's going to do is it's going to retrieve the group key from the stat dictionary, so from this variable called stat, and which will give us a group is will be a list of dictionary, each like with a class value of for example class value of 1, and with some of the total area of each of the class. So the class value 1, which for example it might represent the first class called evergreen, so and its sum of the total area will be represented. And the next step, so we're going to create a loop function. So for example, I'm going to create a variable feature list is equals to group dot map function f. So it's going to loop over each elements of f in the list of groups. And the next step, we're going to convert each of this we're going to convert each one into a dictionary, so we can access the key inside. So to do that, we're going to mention f is equals to earthengine.dictionary f. And the next step, we're going to extract the land cover class, the class value as well as the sum of the total area. So to do that, we're going to mention a variable class value is equals to earthengine.number f.get class value. And similarly, to get the area, we're going to mention a variable area is equals to earthengine.number f.get sum. Sum represents it's going to represent the sum of the total area of this particular class value. So for example, the class value 1 which represents evergreen, so the one class value 1 will be represented as evergreen, and the sum will be representing the sum of the total area. And we are using earthengine.number to convert both of this the class value and sum into the earth engine object for our arithmetic operations. So for that we are using earthengine.number. So in the next step, to safely assign the class name, we're going to first mention a variable called class name is equals to earthengine.algorithm.if. So we're going to assign a human readable class name, for example evergreen, build up, or water bodies. So basically we're going to assign a class name with a new class name, the class name to our numeric class ID. So previously we have used the class value which will be in numeric. So now to give it as a human readable class name, we're going to create a variable called class name is equals to earthengine.algorithm if. So if we're going to mention class value dot greater than or equals to 1, and the class value dot lesser than or equals to class name dot size function. So what is going to do is this code is doing is make sure that it's going to ensure the class value is within the valid range. So you don't go out of the bound here within those 17 classes. And the next step, we're going to retrieve the class name from the list. So based on the indexing, based on the index value, there is the zero based indexing here. So the value, we're going to start the classes from 0 to 16. So the 0 will be represented this particular class called evergreen. So for that, we're going to subtract by 1. So to do that, we're going to mention class name dot get class value dot subtract 1, and we're going to mention as unknown here. So the default label if the class value is invalid, in case the class value is invalid. And the next step is we're going to create another we're going to use this particular variable called class name is equals to, so equals to earthengine dot string. We're going to mention this particular class name. We're representing this variable So basically what we are doing here is we convert the result into a string. So for example, if the class name is of in the list of starting from forest, urban area, water body, or evergreen forest, so the class values will be represented. 2 is the 2 class value will be equals to 2, and the class name will be urban. So basically it's going to convert into the result into a string. So in the next step, we're gonna return earth engine dot feature, and we're gonna mention the null, and followed by either year will be mentioned as year, and the class value will be mentioned as class value, class name as a class name, and area in square kilometer as a area. So it is very useful in case if we are exporting this particular value LULC values as a CSV. So in that case, it will be very useful. So these will be representing the different columns in our Excel. So it's going to create a feature for each land cover classes containing year, class ID, and class name, and area in square kilometers. So for each feature represents one LULC category for that year. So in the next step, we're going to return earth engine dot feature collection and as a feature list. So after mapping through all these LULC classes, so it's going to convert the list of features into a feature collection, which is ready to export as a CSV file format, and also in case we are going to perform time series analysis as well as the visualization purposes. So in the next step, we're going to apply this particular function to all the years. So to do that, we created this particular function called so the get LULC. So we are going to apply this particular function to all the years. So to do that, we're going to mention a variable. So to apply this particular function to all the years, we're going to mention a variable yearly area is equals to earth engine dot feature collection year dot map get LULC. So we are applying this particular function, and we're going to mention dot flatten function here. And last, to visualize it, we're going to mention print land cover area per year and yearly area dot limit 10. So we're going to limit the result up to 10 here. So now let us run this code. So let us run this code and visualize the result here. So let us take a look at the result here. So in the console section, you can able to see here we have our the land cover area per year. So we're going to click this option here, and going to click this option. So here we have a list of features here starting from 0, 1, 0, 0, 0, 1, 0, 2. So we're going to click one of this feature. So the geometry, the properties, you're going to click the properties. So in the properties, you can able to see the area and class name and the class value as well as the year. Similarly, in the next feature, I'm going to click the properties. So you can able to see the area, and the class name is mixed forest, and the class value is 5, and the year is 2001. So let us take a look at the time series analysis here. So you can able to see the chart here. So the MODIS land cover area changes from 2001 to 2024, and the area is in square kilometers starting from 2000 to 2024. So I'm going to click this option and visualize the graph in more detail. So you can able to see the values here. So for example, I'm going to click this particular value, so which represents this particular portion here. It gets highlighted, and for example, I can select mixed forest. So it's highlighted below. And in case of woody savannas, so I'm going to click this option. So you can able to see the woody savanna is pretty high in this study region. So we can able to see the area changes of this woody savanna, and it's kind of stable. You can able to observe from this here, from this graph. So it covers an area of around 16,000 square kilometers of area, and you can able to see the trends here, the upward and downward trends. You can able to observe in the different periods. And similarly, for example, this particular one, let me select this particular one. So I'm selecting this particular one called evergreen. So you can able to see the evergreen in this graph here. So it is around 7,160 square kilometers in 2000, and in 2021 it is around 8,696 square kilometers of area. It covers the evergreen class. So this is the evergreen broadleaf forest. And the next set of class I'm gonna select is So you're going to select this particular one, the cropland natural mosaic. You can able to see it's get highlighted here. So the cropland is also pretty high compared to the evergreen forest in the study region. You can able to see that. So the croplands is around 7,000 square kilometers of 9,000 square kilometers of area. So some small shift you can able to observe in the croplands here. So in the different time period from 2000 to 2024. And other set of classes. So this particular study area is kind of unique, and it has a large number of green areas. So compared to the other part of the world, this particular study region has a high good number of green area. So let me close this. I'm gonna get back to Earth Engine. So in our next step, we're gonna export the area data as a CSV. So to do that, they're gonna mention export.table.to-drive. Collection, they're gonna mention is yearly area. Description is MODIS LULC year by year, area by year from 2001 to 2024, and the file format is as a CSV. So let me run this code. I'm gonna navigate to this option called Run, and I'm gonna click Run. So in the task section, I'm gonna click this option here. So we have this unsubmitted task here. For example, the MODIS LULC area by year. So I'm gonna click this option, and we have the window pop-up saying initiate table export. So we're gonna export as a CSV, and the file name is MODIS LULC area by year 2001 to 2024. And I'm gonna export to my Google Drive. So selected my drive here, and I'm gonna click option Run to execute this code here. So now it's going to take less than a minute or two to export this particular Excel file to my Google Drive. And the next step is what I'm going to do is we're going to visualize and export the land cover for this selected area. So for example, we're going to select this particular year, that is 2005. So we're going to select this particular year and export this particular land cover data. So before that, let me navigate to the layer section, and this is our study region. So this is a state called Kerala. So this is our region of interest. I'm going to export the LULC data of this particular study region, so we can able to see the study area. So we're going to select the year. So for that, I'm going to mention variable selected year is equals to 2005. So we can enter any year of your choice from 2001 to 2024 of your choice, and you can export that particular year of your choice. For example, so I mentioned as 2005. And the next step, we're going to define a variable image year is equals to modis lc.filter earthengine.filter.calendar range, and selected year, that is the start year and the end year, and the unit is in the year. And the next, I'm going to filter it, I'm going to apply .first function to select the first image out of it. So for that, I'm going to mention .first function. Next, I'm going to select LULC type 1. So there is a LULC type 1, there is a band, and the next, I'm going to clip it based on our region of interest, there is .clip study area. And to add this layer, I'm going to mention map.add layer image year IGBP vis, that is visualization parameter, land cover plus selected year. So it's going to mention the year, land cover name it's going to mention as land cover plus the year as a 2005. So now let us take a look at this image. You're going to run this code and visualize the result here. And let me zoom into the study area. So you can able to see this particular image here. This is about LULC, so of the study area Kerala. So you can able to see it contains around 17 different classes here. So each of the color represents a different set of classes here. So you can able to see. So we can use this particular one here. And for example, the dark green, which represents the evergreen, need the needle leaf forest. So we can able to see that. And the water will be represented in blue here. So you can able to see. So the water class will be represented as blue here. You can able to see the class called water bodies. And next step is we're gonna export this as a GeoTIFF to our Google Drive. So to export this image to our Google Drive, we're gonna mention export.image.drive, and image, you're gonna mention image year, and the description I'm gonna mention as MODIS land cover plus selected year. So it's gonna mention the year as a 2005, and the file prefix MODIS land cover plus the year. The region is study area. Spatial resolution of this data is 500 meter. The coordinate reference system is EPSG4326, and the max pixel is 1:10 power 13. So now to export this image to our Google Drive, we're going to navigate to the task option here, and we have this unsubmitted task called the MODIS land cover 2005. So to export this image, you're going to click this option called run, and the coordinate reference system is EPSG 4326, scale is 500 meter, and we're going to export to our Google Drive. The MODIS is MODIS land cover 2005, and the file format is GeoTIFF. So now to export this image to your drive, we're going to click this option called run, and it's going to take around less than a minute to export this image to our Google Drive. From there you can download this image, and so the process started. So previous the MODIS the CSV file has been exported to our Google Drive, so you can open in the drive here. So here you can able to see our MODIS MODIS LULC area by year from 2001 to 2024 as a CSV, and even our MODIS land cover is got exported here. You can able to see. So let me navigate over Earth Engine. So we can able to see the MODIS land cover data has been exported to our Google Drive. So the last step is we're going to perform the time series analysis. So to perform the time series analysis, we're going to mention variable charts equals to ui.chart.feature.groups, and the feature is yearly area, and the x property is year, and the y property is in area in square kilometers, and the series property is in class name. And we're going to set the additional options to this particular chart here. So using .set chart, type is line chart, and set options using .set options. Title MODIS land cover area change from 2001 to 2024, and the h-axis, the title is year, and the v-axis is the area in square kilometers, and the line width is 2, and the point size is 4, and the legend gonna position it towards the right here. The colors, these are the following set of colors for each of the LULC classes here. And last, to visualize this as a time series chart, we're gonna mention print.chart. So we can able to see this particular chart here. So I've shown you earlier. This is the time series chart from 2000 to 2024. So it contains around 17 different classes here. So you can able to see starting with evergreen, and we're gonna move on. I'm gonna click this option here: savannas and croplands, barren, and water bodies and open shrublands. So in this video I have shown you the global LULC change analysis from 2001 to 2024 using MODIS dataset in Google Earth Engine, and I have shown you how to compute land cover area in square kilometers and export it as a CSV, and last to compute any land cover year of your choice and export to your Google Drive, and last we generated the LULC time series chart. So thanks for watching, and make sure that you subscribe to our channel and give us a like.